Hey guys, we rushed through this example a little bit in class, so I just wanted to take a moment and do it nice and slow. This way, if you were confused, you had the chance to, rewatch this example. Okay, so here you're given some information. An animal weighs 3 pounds at birth, and you're told that 3 months later it weighs 4 pounds, and that the weight of the animal is increasing at a rate that's proportional to its weight. So that means that D, whatever letter you want to use, I'm going to use W for weight, dW dt is proportional to, means is a constant times the weight. So once you know that, we'll ask you to set up a differential equation for the scenario. We've done that. This is a differential equation that models the situation. So then it asks you, well, how much does the animal weigh at 5 months? So in order to do that, we're going to need to solve this differential equation. If you don't remember how to do that, like if you don't remember what the answer automatically is, then you can always go through, separate, integrate, solve for C, then solve for Y, or W in this case. But once you know that it follows this differential equation, you can just jump to its the fact that it's exponential growth. So normally we write that as Y equals C e to the kt. But here our Y is W, just because that's what we picked. But if you picked Y to represent it, it doesn't matter, that's fine. So now let's talk about any of the other information that we could plug into this. So we know that C represents the initial amount, whatever the population or the weight or whatever it is when it's at time 0. So it told you that the animal weighed 3 pounds at birth. So that tells us that C is 3. So I know that my equation is W equals 3 e to the kt. I don't know the value of k, which I would need if I wanted to plug 5 in for time to figure out what the weight is. But they did tell me a point. So they told me that at time equals 3, the animal weighs 4 pounds. So we're going to use this piece of information to find the value of k. So I'm just going to plug it in. So 4 equals 3 e to the k times time, which in this case was 3. And I'm just going to solve this equation out for k, because now k is our only unknown. So 4/3 equals e to the k times 3, and then in order to solve for k, I'm going to have to take the natural log of both sides. So if you ln both sides, we get the ln of 4/3 equals just 3k. And then we're going to divide by 3 to get the k alone. So let me figure out what that is real quick. I feel like I just did that. Of course. Alright, sorry. So the ln of 4/3 divided by 3. And that is 0.096. Alright, so now we know our equation. So now I can just write the whole thing out. So it's 3 e to the 0.096t. Then if I want to know the weight when the animal's 5 months old, I'm just going to plug 5 in for t. So 3 e to the 0.096 times 5. And then if at all possible, you should always leave as much stuff in your calculator as you're doing this work, so that it doesn't round at all. So times 3, and it comes out to be 4.8 pounds. So 4.845 pounds. Should always give your answer 3 decimal places. Alright, so this last example just asked us to find out the value of k for a certain doubling time. So a population y grows according to this differential equation. So once they tell you that differential equation, you automatically know the original equation. You don't have to go through the whole separation of variables. You can if you forget, but you don't have to. So they tell us that k is the constant and t is measured in years. And it doubles every 7 years. What's the value of k? So let's take this and let's jump right to that equation. So y equals c e to the kt. So now we don't know the value of c, but it doesn't really matter. We know that in 7 years the population doubles. So you can pick any value of c and any value of y that corresponds to it doubling. So if you want to make this, I don't know, the population's 100, and then 7 years later the population's 200, that's fine. you can just make it 1 and 2, because once you divide by 100, whatever numbers you put here, if it's double, then once you divide by that, it's going to be 2. So if you want to just like jump to that, you can. I've plugged this 7 in for t because that's what they told us is the amount of time required for it to double. Now I'm just going to solve this for k. So I'm going to ln both sides and then divide by the 7. So k ends up being the ln of 2 over 7. Which, whatever, you can do that in your calculator. Just please message me if you have any questions. I'm happy to help you guys. All right, thanks, bye.